Okay, good afternoon. This is Professor David J. De Los Reyes. It's January 26, 2023. For this afternoon, I will now be discussing another example problem under differential equation, which are non-homogeneous, meaning the right-hand side is not equal to 0. Okay, let's proceed for this afternoon. The numbering of the lesson is now, we are now on an advanced mathematics lesson number 7. And for this afternoon, we are solving a problem of the second order non-homogeneous differential equation, in which non-homogeneous meaning the right hand side is not equal to 0. Okay, hold on. I will check my camera. It's fine. I will try to give you another problem for this afternoon, and this will now be example number 6. The given second order non-homogeneous differential equation is y double prime plus 4y equal to 3 sine of 2x. I think we have solved this one from the past lesson already, but the sign of the term on the left hand side, this is actually negative. So for this afternoon, we will be solving the same problem, but this is plus. Same right hand side. Let us try to say the variation on the solution of the so-called particular solution. Because for sure, the solution of the particular will be different from the previous one. If this is negative, supposed to be, the solution particular will be different. Okay, let's proceed with the solution. The problem is asking for GS. GS meaning general solution. Since maybe the constants of integration, okay, are not known. That's why it's general. Okay, let's try to bring out the solution. The first part of the solution is actually the complementary solution, because total solution is actually complementary plus particular. So let's try to solve first for the complementary solution. And as always, the start of the complementary solution, we will start with the substitution. Y sub c is equal to Ka to the mx. C here refers to complementary. Taking the first derivative, y prime c equal to Km e to the mx. Taking again the derivative of the first derivative, what will come out will be the second derivative of the complementary solution. For the meantime, it is the complementary we are considering. Y double prime of c will be a Km square e to the mx. As always, it's always the same as like that. Substituting Km square plus 4k e to the mx, we are following this, equal to 0. At the time we are solving the complementary solution, we will equate the right hand side to be 0. Okay, then try to simplify the resulting equation after the substitution, and what will come out will be an m square plus 4 equal to 0. Because if we try to multiply all the terms by the reciprocal of k e to the mx, this k here will disappear. Okay, and e to the mx will also disappear. This is multiplied by 1, so m squared times 1 will be an m squared, plus 4 times 1 will be plus 4, and this should be equal to 0. So we are now given the characteristic equation. This is termed 2 as the characteristic equation. And to solve for the characteristic equation, okay, it's a quadratic equation. You either factor out or use your knowledge of the so-called quadratic formula. But since this is just simply an m squared plus 4, we could solve for the value of m directly. M squared now will be negative 4. M squared equal to negative 4. Taking the square root of both sides, this will become the square root of negative 4. And we will replace negative 4 is actually negative 1 times 4. And negative 1 is actually g squared. 4 square is actually 2 square. They are both perfect square, so what will come out will be plus or minus G2. So I place it here, M is actually plus or minus G2. It's a complex solution in which the real part is actually 0. The imaginary part designated by beta is equal to 2. So the complementary solution now will be K1 cosine of 2x plus K2 sine of 2x since alpha is 0. Because the general solution is actually e to the alpha x K1 cosine of beta x plus K2 sine of beta x. But if alpha is 0, this will become 0, right? And e to the 0 will be 1. So this will be times 1. So the complementary solution will just be simply K1 cosine of beta x, or 2x rather, plus K2 sine of 2x. Okay? As simple as that one. I will check my camera. Oh, it's still fine. Okay, let's try to bring out the particular solution. For the particular solution, I think the solution the last time around, if this is minus, it is not the same as this. Okay? It is different. So for the meantime, we will try particular solution, meaning y sub p will be the product of x times the quantity a cosine of 2x plus b sine of 2x. This 2x here and this 2x here refers to this. We'll follow this one because we are finding for the particular solution considering the right hand side. So for the meantime, we do not know the value of a, we do not know the value of b. X is just x, okay? That's our assumed particular solution. You could assume any particular solution you want, okay? But if after substitution, okay, you cannot formulate the equation on how to solve for the value of a and b, there is a problem with your particular solution. But for this one, I am sure, because I have checked it already, that the particular solution should be y sub p equal to the product of x times this quantity here. Okay, let's proceed with the solution. We need a y double prime here, right? So we must take first the first derivative. Y prime of particular, we will take the first derivative of this. X times this quantity, it falls under product. So it will be first times the derivative of the second plus the second times the derivative of the first. So x will be negative 2a sine of 2x plus 2b cosine of 2x, okay, plus the second part, a cosine of 2x plus b sine of 2x, I'm just following this, times the derivative of x, which is 1. Oh, this is minus 2a sine of 2x because a, the derivative of cosine will be minus 2 sine, right? But the derivative of the angle is minus 2. So a times minus 2 will be negative 2. This will now be negative. This one here, it should be b times the derivative of sine, which is cosine, times 2. So this will be 2b cosine of 2x. As simple as the one. Product formula. And the derivative of a sine in cosine function. Take again the second derivative. Okay? The derivative of the first derivative will be the second derivative. Oh, just take this one as the product of two functions. And this is a sum. So if we try to take the derivative of this, it will be x times the derivative of this. This will now be negative 4a cosine of 2x. Why? Because minus 2a times cosine will be 2a cosine of 2x, but the derivative of the angle is 2, so this will now be minus 4a. The second part, it should be 2b. The derivative of sine will be the derivative sine is plus cosine, but the derivative of the angle is 2, so it should be 4b. Okay? 2b times 2 will be 4b sine of 2x. Plus, this is the second part, right? So I will just rewrite it. Okay? Times the derivative of the first, which is 1. Plus the sum of the derivatives of the last two part here. This should be negative 2a sine of 2x. This will be negative because this is cosine, right? a times minus sine of 2x times 2. This should be negative 2a sine of 2x. Second part, it will be the derivative of sine will be cosine times 2. So it will be 2b cosine of 2x. Okay, as simple as that one. Don't make a mistake on the simple differentiation, okay? Simplifying. Y double prime of p, the particular will be after you expand this one, then try to simplify. I didn't show you, but I will now give you the final part. It should be negative 4ax cosine of 2x minus 4bx sine of 2x minus 4a sine of 2x plus 4b cosine of 2x. This is x cosine of 2x, this is x sine of 2x, this is just simply sine 2x, this is cosine of 2x. Substituting the value of y double prime in y back here, then equate that to 3 sine of 2x. If we try to put the value of the second derivative, this is the one on the first quantity, it is this one. Okay? And if we try to multiply y particular by 4, the first part will be 4b cosine of 2x. No. 4a cosine of 2x. We will multiply this by 4. So this will become 4a cosine of 2x. This is plus 4b sine 4bx sine of 2x because there is an x over here. Okay, I expand already. So this is 4ax cosine, this is 4bx sine. And this should be equal to the right hand side. For the meantime, we are considering the particular, so we will take the value of the right hand side. Okay, this will be 3 sine of 2x. And luckily, this one here cancel with this. Okay, and this one here, okay, for Vx, cancel with this. Okay, so what remains is actually this part here on the left hand side and this part here. Okay, and b should be equal to 3 sine of 2x. It is just simply a sine function and a cosine function on the left hand side equal to 3 sine of 2x. To solve for the unknown value of a and b, we equate coefficient of like terms. There is a term on the left hand side with the term sine of 2x. So on the left hand side, the coefficient of sine of 2x will be negative 4a. And on the right hand side, it is equal to 3. This is sine of 2x, sine of 2x. This is equal to 3. So a now will be negative 3/4. Okay? For the cosine of 2x, okay, the coefficient is 4b. Considering for the meantime cosine of 2x. 4b. And on the right hand side, it is 0. There is actually plus a 0 here times cosine of 2x. Okay? There's a cosine of 2x. But unluckily, the coefficient is 0. Okay? So we place it here, 4b equal to 0. The coefficient of cosine on the left hand side is 4b. And on the right hand side, there is a cosine of 2x. You are not just seeing it because unluckily it is 0. So this should be equal to 0. So b now will be 0 over 4 or b is equal to 0. Okay? So to bring up now, the particular solution we will follow this. Okay? This b here is 0. So this will become 0, right? And this is negative 3/4. So the particular solution now will be equal to negative 3/4 x cosine of 2x. That's the particular. Okay? There is no unrealistic thing if we try to equate coefficient of like terms. But if there is an unrealistic thing, our assumed particular solution is wrong. But since A is a real thing and B is a real thing, okay, the assumed particular solution is correct. Therefore, the particular solution now will be negative 3/4 x cosine of 2x. So the total general solution will be y sub c plus y sub p. Y sub c is this one. K1 cosine of 2x, K2 sine of 2x. plus the particular. Okay, plus open quantity negative 3/4, so this will be simply negative 3/4 x cosine of x. The operation is addition, plus any minus will still be minus. Okay, so this is minus 3/4 x cosine of x. This is our particular total general solution. Okay. To check the validity of our answer, we take the second derivative of the total solution. Okay. And this is the total value of the second derivative of the total general solution. Okay, I will continue it here. We are checking the validity of our answer, right? So y double prime will be, okay, minus 4q1 cosine of 2x minus 4q2 sine of 2x. I'm copying this one. Plus 3x cosine of 2x plus 3 sine of 2x. That's the value of this. Okay, I just rewrite it here. I've got already the second derivative here. This is the differentiation, this is the simplification. Plus, we will take the particular solution, or the total solution, we multiply it by 4. We will multiply all these terms by 4. So what will come out? It will be plus 4q1 cosine of 2x. We multiply this by 4. Plus 4q2 sine of 2x. Negative 3, 4 times 4, what will come out? Negative 3x cosine of 2x. Okay? And what will be the sum? Is it equal to 3 sine of 2x? Because the right hand side is actually y prime plus 4y. It is all of this. And if we try to simplify, this one here cancel with this. 4q2 cancel with this. 3x cosine of 2x cancel with this. Okay? So actually what cancels are actually 1, 2, 3, 4, 5, 6. And what remains on the, after taking the addition of y double prime plus 4y, it is 3 sine of 2x. So meaning, after taking the first, the second derivative, we add 4y. What comes out on the right hand side is 3 sine of 2x. Why 3 sine of 2x? Because what remains after the cancellation is 3 sine of 2x. And this 3 sine of 2x is actually this. Okay? So we are absolutely correct. Okay, that's it, guys. That's the proper way. I'm checking my camera. That's the proper way on how to check the validity of our answer. Taking the second derivative, you add the 4 times product of the total particular general solution, take the sum of the left hand side. So, yeah, sum y prime plus 4y equal to 3 sine of 2x. So we are absolutely correct. Okay, that's it, guys. That is for this afternoon. So this is our total general solution, and it was really correct as per verification. Okay, after taking the second derivative and add the 4y value on the left hand side. Okay, for those people who are taking, or students taking the advanced mathematics, this is for you guys. If you like my video, please click like. And if you want to subscribe to my channel, you will get something from it. My channel is actually at youtube.com/@ProfDavidJ. And if you want to share it, please click share. Good afternoon, Los Angeles.